Hey everyone, today we're going to be using WAGMI to build an UMA insurance Dapp front end, and the front end will be built in React using TypeScript. And on top of React, we're going to use WAGMI, which is a library of React hooks for Ethereum. And the benefits of WAGMI are it has pre-built React hooks for standard tasks like connecting to different wallets, ENS profiles, and interacting with ERC20 contracts, and it will also generate custom webhooks for our smart contracts. So we can easily interact with our contracts and avoid a lot of the Web3 front end pitfalls. And WAGMI also has a create-wagmi CLI tool, which allows you to quickly set up a project and has pre-made React components for some of those standard React hooks, like connecting to wallets. WAGMI is built on top of Viem, which is a TypeScript interface for Ethereum, basically like a TypeScript version of Ether's JS. And so in some instances, we'll be using Viem directly rather than through the WAGMI React hooks. And so this tutorial will focus on how to use WAGMI and Viem to build a front-end Dapp, and it won't cover all of the basics of React and TypeScript, so you should have at least some knowledge of those. And we'll focus on building a performant Dapp so that repo won't be using any styling. It's just vanilla HTML. So this is the front end we'll be building today. As you can see, there's no styling, it's just HTML. We have a title here, and then we have a connect panel, and then we have an existing policies panel with a table showing all the information on the existing policies. And you can see we have three different options to connect our wallet to the front end, and these all just come pre-made with the WAGMI repo. So we have MetaMask, we have Coinbase Wallet, which this is the login modal for, and Injected. And Injected is going to be any browser extension you have installed that injects the Ethereum object into your browser window. And so for me, I just have the MetaMask extension installed. So Injected and MetaMask connectors are basically going to do the same thing. So I'll go ahead and connect with MetaMask and select the address I want to connect. And the front end, once you're connected, displays the account address, and it'll also show the ENS domain if there is one. Also have a network switcher, which right now we're connected to Goerli, which our Dapp is going to use, but there's also a button to switch to the Ethereum network. I'll zoom in now and show the transaction flow. So you can see right now the approve and issue insurance buttons are disabled, but once I enter in an amount and paste in an address, the approve a button will become available. I'm going to select the smart contract hack event and click approve. And I'll confirm that in MetaMask. We get a processing transaction message with a link to the Etherscan transaction hash. And once that's gone through, the approve button will become grayed out and we'll have the issue insurance button available. And I'll confirm that in MetaMask as well to send the transaction. Once that's gone through, the new policy is added into our existing policies table without refreshing the whole page. Other functionality we have in the existing policies table is for closed or requested policies. We can view them, the request on the Oracle that verified that the policy should be paid out. And we can also request a payout for an open policy. So if this flood has now happened, I can assert to the Oracle through this button that it's happened and I should be paid out. And once that request has gone through, the status will update and we'll get a link to the new assertion that the flood has occurred on the Oracle front end. So now that we know where we're headed, let's get started. We're going to be using the WAGMI create-wagmi repo. And I'll scroll down to the README, and we're just going to follow the commands here. And they have a number of different templates, but we're not going to be doing a server-side app, so we won't use Next. We'll just use Vite React. They have integrations for Foundry and stuff like that, where it'll pull from your Foundry contracts. But we're just going to use the vanilla Vite React CLI ABI. So I'll flip over to my terminal. guess it didn't notice my template, but I can select from the list here. I'm going to use Alchemy as my provider, and I won't put in a wallet connect ID. Now it's going to install packages. So now I have our repo open in my code editor. Just before we get started editing anything, I'm going to run npm run dev in my terminal, and that is going to start the local development server, just so we can see that the local development server is working before we make any edits. So if you have any issues getting this set up, something is wrong with your cloning of the repo. First folder is ABIs, and so they have one example ABI in here, which I'm going to select all and replace with the insurance v2 ABI, and that will be in the linked repo. One thing to be careful here when you're defining your ABIs is that it's exported as a constant variable, but then you also have to set the type to a constant at the end of your ABI. So that messed me up. Lost some time to that. And I will rename that to suit insurance v2 ABI. And all the ABIs in this ABIs folder will be used by WAGMI to create React hooks using the CLI commands. And so that's really handy. And so you can use this example ABI to follow exactly along, or you can get ABIs for your own smart contracts, or even download ABIs from Etherscan from verified contracts. We also have all our npm node modules, of course, that we'll be using in this repo. And then the source folder has all our React files. So it has all the individual components, and then the app and the main files, and then also the generated file. So this is the file that WAGMI's going to generate based off our ABI and our WAGMI settings, and it's going to create a bunch of React hooks that we're going to use to interact with our contract. And so this is going to be automatically generated by WAGMI. We won't be editing this at all manually. And the WAGMI file sets the config that we'll be using. So we'll come back to the source file. We have a .env.example, which I'm going to copy and paste a copy of it, and just edit this to .env. And then you should paste your own Alchemy API key in here. Don't include the rest of the URL, just the actual API key. And we'll use that to access information from the blockchain. And scrolling down, there's a bunch of setup files which we won't be editing, but we will be editing the wagmi.config file. So the first thing I'll do quickly is just select all the WAGMI Mint examples and replace them with insurance v2. I don't know, I think I had an ABI in here. I'm just going to capitalize the name here. So in this WAGMI config file, we have all the contracts we're going to want to interact with React hooks. And so we define the ABI, the name, and then also the address for the different chains that we'll be interacting with the contract on. So we're not going to use mainnet, so I'll delete that line. And then I have the contract address here. I'll copy and paste in. So I've already deployed our insurance v2 contract to this address on Goerli. And then the one other contract we're going to want is the ERC20. So because we're going to be approving and reading allowances, we're going to want an ERC20 contract available to us. And so WAGMI automatically supports the ERC20 ABI. I don't have to copy and paste it in. And you also don't have to define an address for it. So I'm not going to define that, but rather in my code, I'm going to just define the address that we'll be interacting uh, with the ERC20 ABI. So that's good for our WAGMI config file. So now I'll open the wagmi.ts file under the source folder. And this is where you set up the chains and your wallet connectors. I'm not going to use the wallet connect connector, so I'm going to delete that import and I'm going to paste in an alchemy provider uh, line from WAGMI. And so in this first function, we're configuring the chains we want. Uh, our Dapp is going to use Gourley, so I'm going to have Gourley and mainnet. I'm going to move Gourley to be first in the array, because then the Dapp will default to Gourley. And then in the next array, we're going to put our providers. And so we already have a public provider which can act as a backup, but we want our alchemy provider to be the default. I'm going to put that up front. And then we need to put in our API key for using our alchemy provider. And we're going to be referencing our .env file. And so the default prefix for Vite projects is import meta env, and then our variable name is Vite alchemy API key. And then in the create config, we add some wallet connectors, which we'll just use the generic MetaMask, Coinbase, and injected. Now that we have all our setup finished, we can open a terminal, and I'll run npm run wagmi, and this is going to use the ABI that we pasted in, plus our wagmi settings to edit this generated file. And now this generated file is going to contain React hooks using our insurance v2 contract. So if you look through here, um, here's a React hook for reading our insurance v2 default currency public variable. And so now we're ready to get into the source folder and actually start editing our app and the React components. So the main folder we'll just leave as is. You can just see the WAGMI config component is wrapping our app. And then we will work within our app file. But before we do that, I'll just quick jump to just a demonstration of how I laid out my app as far as React components. So we have the connect, account, and network switcher components, which these are all just the generic WAGMI components that came with the repo. And then I think we'll set that up first, and then we'll get into the policies. Um, so basically all I'm going to do is create a title and then put these three components in. And like I demoed before, the account and network switcher are only going to show up when our wallet is connected to the Dapp because we have no account to display without being connected. So let's get those three components set up. So first I'll just edit this heading. And then I'm going to keep the connect as is. And then you can see right now they have is connected. And so is connected is a variable that is pulled from the WAGMI use account hook. And so basically that's going to be true when there's an account connected and false when there is no account. So by using is connected and then putting our React components in here. These React components will only render when is connected is true. So I'll just put in h3 of account in here just so we can clearly see division between the components. We won't be using this component, so I'll delete that from our import statements and I'll delete it from our component list while I'm at it. And so now we should be able to run npm run dev again, and we shouldn't have any errors, and it should be generating our front end. So now we have our title, and when we connect, we have our account and network switcher. So just like that, we're basically halfway done our front end, which is kind of a joke because the other half is actually going to require writing some code, where this half was just the default WAGMI components as part of the repo. But if you do actually look at these components that we're making use of, they are actually very simple just because all of the real work in the components are being done by the WAGMI React hooks. So you can see in the account component, we're just getting the address from the use account hook, and it'll even grab the ENS name if there is one from the use ENS name. Connect is also pretty simple, just again making a use of a bunch of WAGMI hooks. And the network switcher, again, a very simple small component making use of WAGMI. Start on the custom half of our front end now. So I'll open the app file under source, and I'm going to import policies component from our components file, and I'm going to put it underneath all the components we have so far. And then I'll open that policies file. And so I've pasted this in kind of a framework, and I'll just run through it. So what we're doing is we are importing some React and Viem functions. We are importing from our generated file. So these are React hooks and contract information that WAGMI automatically generated in our generated.ts file. So we're going to import the insurance v2 address. So that's the deployed address of the contract. And we're going to also import the ABI, which we'll use later. And we won't go too far into this component yet, but you'll see we have the React use effect hook, and we're going to set that up to run on page load. So basically, we're not passing in any components into the second argument of use effect. So that means it's only going to run on page load. And when that runs, we're going to run this get policy IDs function, which we have defined here. And that's going to go through our smart contract and get all the policy IDs of those that have already been created. And so we'll do that later in the video, but the key thing here is we're going to pass this function into our new policies component so that when a new policy is created, it can call this function, and our existing policies table will automatically update to include that new policy. And then in the returned HTML of the policies component, we have basically just our table of existing policies. And then above that, I'm going to put in our new policy component. And we're going to have to pass the get policy IDs as a prop. So now we have that component in here, but thing is, the new policy form, I only want that to show up when we're connected. So I am gonna flip over to our app and grab this same logic here so that basically this code will only run when there's an account connected. And of course, to do that, I'm going to have to grab uh, the is connected variable, which is on this WAGMI use account, this WAGMI hook. So I'll add that in here, and then I'll have to add use account, import that from WAGMI. Okay, so now if I flip back to our front end, you'll see we have our form here. So let's get into the new policy component now. I pasted in a framework for it here with basically all the import statements we need from React and WAGMI and Viem, and then also from our WAGMI generated file. So you can see these are all the React hooks we will use to read information from the blockchain, approve our ERC20 spend, and then actually execute the transaction to issue insurance. And yeah, I won't cover the vanilla React and HTML stuff, but we have our state variables here for our form. I just have array of strings for different events that are going to be able to be selected from the front end. I have one uh, custom method here for updating the amount state just to make sure that the amount is always a number. Then I have the HTML here for our form. So basically two inputs for the policy amount and payout address, and then a select for the event. And then here we have our buttons, which I've left some empty fields here to fill in with some of the variables that are dependent on our WAGMI hooks. And then at the bottom, there's also a processing message component that will be used to display the processing transaction and Etherscan transaction hash link when the transaction is processing. Let's start by coding our WAGMI read-only hooks. So these are WAGMI hooks that are going to be reading information from the blockchain from view-only functions. So the first item we'll need is the user address. And so we're gonna get this from the WAGMI use account hook, which the WAGMI use account is gonna return an object, and one of the keys on that is the address. And so we're gonna set the user address to the address value of the object. And then uh, the next one we'll need is the token address. And so this is on the insurance contract that we're using. There's a public variable, public address that's the token that's used for paying out the policies. And so that's going to be insurance v2 default currency. So that's the default currency is the name of that public token address. And now that we have that token address, we're gonna get the token data for that ERC20 address. And we are gonna use the WAGMI hook use token. So this is a default um, React hook that comes with WAGMI. And so basically for any ERC20, you can use the use token and give it the address. And now this hook is gonna look on the blockchain at this address and pull down all the token data, um, assuming that that token meets the ERC20 standard. And so from that token data, we're gonna get things like the token symbol. And then the last read-only hook we're gonna use is the ERC20 allowance that the our user has given our insurance contract. So this hook is going to return the allowance on an object's data field, and it's also going to return um, a refetch method, which is going to allow us to check for an updated value of the allowance. And so for this hook, we're going to have to pass some args because if you're familiar with the ERC20 token contract allowance, you have to give two addresses, right? The address of the potential sender and the address of the receiver, and that will return the address. So I'm going to use for the first address the user address. So this is the address of our connected wallet. And then the second arg is going to be the our insurance token contract. That should be capital. And so this insurance V2 address came from our WAGMI generated file. And so you can see uh, that file has the address on chain ID 5. So we're using Goerli. So that's why we use chain ID 5. And then that address is the one we put into our WAGMI config file. And so we have access to it through this generated file. And then the one other thing we need to include in this hook is the address of the token that we're calling. So just to run through this again, this use ERC20 allowance is going to call this token address, and for args, it's going to pass our connected user address in the first field, and the second field is going to be the address of our insurance contract. And we are going to set the returned data as the variable allowance, and we are also going to create a new function variable called refetch allowance that is going to refetch this value when called. So now that we've written out our WAGMI hooks for reading from contracts, we're going to write our WAGMI hooks for writing to contracts and actually sending transactions. And that's going to be done through 3 different hooks. So we're going to use prepare ERC20 approve, and we're going to put in our args and the contract address that's being targeted. And what that's going to do is WAGMI is going to use this hook to be constantly checking if the values put in the args and address field create a valid transaction. And then once that transaction is valid, we're going to pass our prove config variable into our use ERC20 approve, and that's actually going to create the transaction. And so the purpose of the prepare hook is if you don't use that, and basically you just put in whatever values into this hook and send the transaction, um, you're kind of guessing that whatever the user has inputted will create a valid transaction. And the issue you run into with that is that the user puts in values and hits the button to send a transaction, and it comes up in MetaMask and it says, you know, gas limit can't be estimated because the transaction they're submitting is going to revert. So this gives a much better UX in that it should give a valid transaction to their wallet for signing. So all that said, let's get into it. So For use, prepare, ERC20, approve, we are going to need two args, I believe it is. Yes, so a string and a big int. And so the first arg, the 0x string, that's going to be the address that you are approving to spend, and the big int is going to be the amount that you are approving them to spend. So the address that we want to approve to spend is our insurance V2 address. And like we talked about earlier, that variable um, has values for all the different chain IDs, and we are using Gourley, so that's going to be chain ID number 5. And then we want to pass our amount for the amount that we're approving the insurance contract to spend. And so we're going to have to uh, parse the amount variable, because our amount variable is a string. And so um, we are going to convert that string to a number. It's using the generic JavaScript, TypeScript number function. And then we are going to use the Viem parse ether function, which takes in a number as a string, and a number as a string in ether, and returns a big int type in way. So that's going to format it correctly for our transaction. And then the address we want to send this to is our token address, which we have available to us on token data dot address. And so I wrote it out like this because I knew that the error is going to come up in TypeScript. So you're going to have an issue that token data may be undefined. So you put a question mark in here that if token data is defined, read address, and we'll pass that in as the address. And then setting up our use ERC20 approve is very simple now. We don't have to put in our args or anything like that because we've already done that here. Basically, we just pass in our approve config variable, which is output from this prepare ERC20 approve, and we pass that in to this hook, which is actually going to prompt our wallet to sign the transaction and send it to the blockchain. And then the last thing we're going to use is another WAGMI hook, use wait for transaction. And this is going to wait until the transaction is confirmed. And then you can use the on success arg to run whatever logic you want on the transaction success. So we are going to pass in our approved data variable here, use a question mark because it may be undefined, and then select the hash off of that approved data object. So now this use wait for transaction knows what transaction it is waiting for. It's waiting for this approved data transaction. And then on success, we're going to pass refetch allowance. And so what that is going to do is it is going to call this React hook again and update the allowance because we will have updated with this approved transaction. So hopefully that made sense. We went through it in a fair bit of detail, basically using the use prepare hook to prepare a transaction. And then once it's valid, we'll make the button available to the user, and they'll be able to click the button and use the use ERC20 approve hook to actually sign the transaction and send it. And then our front end will use wait for transaction to update the state after the transaction's complete. And so this was all for the ERC20 approval, but once the user has finished the ERC20 approval, of course, they'll want to actually execute the issue insurance transaction on our insurance contract. So we have basically the exact same flow here with the three WAGMI hooks. We have use, prepare insurance, V2 issue insurance. So that's just use prepare, and then insurance v2 is our contract name, and then issue insurance is the function. And then we pass in the args here, which the args for that function are the amount of the insurance as a big int, and then an address, which is the address that will be paid out on the event happening, and then the event, which is passed in bytes, so it's also a 0x string. And then that issue insurance config, once these args are a valid transaction, it will pass that on to the use insurance v2 issue insurance, and this will actually prompt the user's wallet to sign the transaction and send it. And then once again, we are listening for that transaction hash. And once it's complete, on successful run. And since the user has sent a transaction based on the form amounts, after that, we're going to want to set the amount back to blank and set the payout address back to blank and reset the form. And then we're also going to call get policy IDs, which is that prop that we passed from the parent component policies. We pass that into new policy, the component we're in currently. And so basically what that's going to do is it's going to look for existing policies again, and the policy that was just created is going to be added to our table of policies. So now we'll go through our returned HTML and update the logic there based on the WAGMI hooks we've used. And so the policy amount, just have in brackets the token symbol. Flip to our front end here so you can see policy amount we have in brackets WETH. And so we had that, we pulled that in using our WAGMI hook. So it's going to be on the token data variable. So I believe if we go token data, use a question mark, of course, TypeScript, and then we are going to return the, not the name, the symbol. So that will be the capital WETH. And continuing down, so that's our form. The rest of the form was all just basic HTML and React. So we won't cover that. And then scrolling down, we get down to the buttons for approve and issue insurance. And these buttons, when they aren't disabled, the user will click on them to actually execute the transactions. So we want the buttons disabled when the user basically can't execute the transaction. So we're going to put in a value in here, and when it is true, the button is going to be disabled. So I'm going to go up to our approval hooks here, and I'm going to just point out the booleans we'll use. So approve write, that will basically be the method called to execute this hook. And so it will only be truthy when approve config is a valid transaction for the ERC20 approval. So we're going to want to make sure that if approve write resolves to false, that button is disabled. And we're also going to want to make sure that when approve is loading, that basically there's an approved transaction happening, that the button is also disabled. So we're going to use those here. I'm going to go bang approve write, so that if approve write is false, the bang will resolve it to true, and the button will be disabled. And then we'll throw in or approve is loading. So if there's already an approval transaction happening, of course, we don't want the user to hit the button again and create another transaction. And then the one other thing, I guess there's two other things we want to check for here. we want, if the user already has an allowance that is greater than the amount they've entered in the form, they do not need to send an approved transaction because they already have an allowance greater than that. Um, so if allowance is greater than or equal to, and of course the allowance will be in way. So we need to convert our amount into way so we can properly compare the two. And so if the allowance is greater than the amount to be approved, of course, there's no point in approving it. So if this is true, the button will be disabled. It's correct. But we're going to run into a TypeScript issue here where allowance is possibly undefined. So I'm going to add a question mark on the allowance. And if allowance is defined, it will be resolved to this Boolean. And if allowance is not defined, so there's no allowance yet set by the user to the insurance contract, then I also want to make sure that the amount is greater than 0. Otherwise, the user could send a transaction, or the approval button could be enabled when the user has a 0 in the amount field, which is, we don't want them to have that button available then. And then the one last thing that we'll check for is that they have an address in the address field as well that is valid. Okay, that's a bit to wrap your head around those 4 different things, but basically if any of them resolve to true, the approve button is going to show disabled. And then on the enabled button, which is after the colon, on click, we are going to run approve write. And that may be undefined because what it's going to say. So I think we need to put a question mark in there. And then beside that button, we will have the processing message when approve loading is true. And so we're going to put that in here and have approve is loading. And we'll use the double ampersand and include the processing message. And the processing message component takes in a hash prop. So I'm going to go hash is equal to the, it's going to be approve data dot hash. And I'll have to throw a question mark in there. And this should be closing the element. And one more curly bracket. Okay, so now when approve loading is true, it's going to show this processing message component and set the approved data hash equal to the hash prop. And then our issue insurance button is going to be basically the same thing. So again, we're going to go bang issue insurance write. So when the insurance issue transaction is invalid, this is going to resolve to true and it's going to show the disabled button. Or when issue insurance is loading, it's going to be disabled. But otherwise, it's going to be active. And on click, it's going to hit the issue insurance write method. And then we will include the processing message as well. We're not going to use these approved variables, but rather it's going to be issue insurance So now that we're able to create new policies, I'm going to go back to our policies component in the components folder, and we're going to get the policy IDs, and that'll be based on past events emitted by our contract. And then we will pass an array of the policy IDs to a policy data component where that'll fill in the row of each table. So first thing, let's define our React state variable, which is going to be policy IDs. Oops, sorry, that should be set policy IDs. That's going to equal use state. And the type of this is going to be an array as 0x string, because the 0x string is the type used by Viem for hexadecimal characters. And I need array there. So that will be the policy IDs that we will set in our get policy IDs function. So now we'll write our get policy IDs function where we're going to query events using Viem. So just because we're making an external call, I'm going to use try and catch just to handle any errors. And I'll put a console log in there too. And then we're going to use Viem's create public client function, and that's going to take a transport, and they have an HTTP function that we'll use to format our RPC URL. So I have the prefix from Alchemy here, and then our API key from our .env file. And I'll just scroll up and show you the HTTP and create public client are coming from Viem. And then we will get the issued event logs from client.getLogs. So this is Viem's client method for querying events. And we're going to search for the event from our insurance v2 ABI. And it is the index 1 in the ABI. And so the ABI is imported from our generated file. And you just have to look through the ABI to find the index number. And then I'm going to go from block, and I looked up already on a block explorer when our contract, what contract block it was deployed at. So I'm just going to put that in there so the query will be quicker because it won't search from the first block of Gourley. And the address of the contract. So we're using insurance v2 address, and then we're looking for the Gourley chain, the ID of 5. And again, the insurance v2 address is coming from our generated file. And then I'll put in some console logs again. Now I'll just stop there, so I'll throw in a catch. And console log. So in our console, I can open up the issued logs that I consoled out, and you can see in the first item, there's a key args and then a key within that for a policy ID, and this is the policy ID we're going to want to set our state variable to. So flipping back to our code, I'm going to create like a shadow variable that shadows our React state variable, and it will be an array of string 0x string, yes, and then I'll use for each on our logs and store logs.args policy ID, which that might be undefined, so I'm going to have to use the double ampersand again. And so if this resolves to truthy, it will be pushed into the policy IDs array. Then after that, I'll set the policy IDs to underscore policy IDs. Okay, so now we'll have an array of policy IDs in that React state variable. And so what I will do now is iterate over that policy IDs state variable. And for every policy ID, I'll create a new row in our table and pass the policy ID as a prop to our new component. And so I'll make a new table row, and I should get the index as well. So every table row has a different key. Oh, this should not be a curly bracket. And then here we will have policy data, and I'm going to pass the policy ID as a prop. And we're having an error here because I haven't imported that yet. I actually have it commented out, but I haven't actually created that file, so I'll have to create that. And so now we will create the policy data component that creates each row of our existing policies table. And just as a reminder, you can see that the policy data uh, component is going to be one row in our existing policies table. And so it's going to include all these different data points from our policy struct in our smart contract. And then under the action column, it's going to include either a link to the oracle to view the assertion that the event happened, or it's going to have a request button that is going to request payout and assert that the event has happened to the oracle. So I've copied in a framework for that, and we have our import statements. We define our component here, and we're taking in the policy ID as a prop, and the policy ID is of type 0x string. And I've just copied in the status enum from our smart contract. Basically, every policy uh, struct has an enum in it with the status. And so the first thing we will do is we will use another WAGMI hook to get the policy struct information based on our policy ID. And so that's a mapping we call with the policy ID as the key. And so the only arg is going to be the policy ID. which is again the key for the mapping. And so for the args, we are just passing in, if policy ID exists, we're passing in the policy ID. Otherwise, we're just passing in undefined. And the result will be in the data child of the object. And so we're going to store that as under the variable name policy. And we're also going to get a refetch method on it as well that we can use to refetch the policy information. And we're going to use that once we hit request payout. We're going to call this refetch function so that our existing policy table updates based on that latest payout request. So I'm just going to write a function for that here. And I'm just going to throw a console log in. And from that function, we will call the refetch. And then we'll put the different policy data into our table. I'm just going to grab our table headings here so I can remember what order to put them in. So the first one is the insured event. And the insured event is in index 1. So basically the order of the struct in the smart contract, that's going to define what index each piece of data is in the policy array. So based on the smart contract, I know that we are looking in the second index for the event. I'm going to use Viem's from hex to convert the event from hex into a UTF-8 string, so it's human readable. And the next one is the beneficiary address, which is in index 1. And then we have the amount, which is in index 0. And I'll use the Viem's format ether to convert that from way into an ether string. And if it doesn't exist, we'll just put in an empty string. Satisfy our types. And then we have our status in index 3, which I'm going to use. The constant array I defined above. What did I mess up here? No, this should be, there we go. So the status enum from the smart contract will just be an integer that is the index of the enum on the smart contract. And so using the index here through our array, we're going to get the string for the current status. And then in our last column, we have action. And so what I have there on the front end is it should be either if a request has been made and it's open, or the policy is closed and it has been paid out already, then we're going to include a link to the Oracle front end. But if it is currently open, we're going to include a request button so that users can request that the payout is made. And so basically, they're asserting that the event has happened to the Oracle. Um, and that is, yeah, the transaction will have on that button. So I'm going to use a conditional statement here that if policy and status enum use policy 3 here equals open. So basically, if the status return from policy is equal to open, we are going to want to use our request payout component, and we're going to pass the policy ID as a prop and the refetch policy as well. And I will uncomment these imports. Again, haven't defined those files yet, but we will afterwards. Okay, so if our status is open, we will have the request payout. And if our status is requested, can't find the bar, there it is, or closed, we will return the Oracle link component. And that will require the policy ID as a prop. And then if the status is set to anything else other than open, requested, or closed, we will just return an empty string. So I just need to close this Oracle link element. And now let's jump over into this new Oracle link component, which I've copied and pasted in. It's mostly all logic we've seen before, so I'll just quickly run through it. We have a new component with the policy ID as a prop, and we have the transaction hash as a React state variable, and we're going to use that transaction hash to create our Oracle link. And we're using useEffect to run our get transaction hash function on page load. And we're again using Viem's create public client and using that client to get logs, and we're filtering for the payout requested event after the block number that the insurance contract was deployed. We are using the insurance v2 address and targeting args of our policy ID. And from that get log, we're going to take out just the transaction hash. And then if it exists, we're going to set our transaction hash to that transaction hash. And then in our returned HTML, we're going to return a link. We'll open the testnet Oracle front end to show you how we can find our link. Basically, just click on an assertion, And then look at the URL here. So we have testnet oracle uma.xyz. And then after the question mark is our queries. And we have transaction hash, which we just got for all of our policies. And then an event index is also included. And just playing around with it, um, it's deterministic when you click on a specific assertion, but if you just leave the event index 0 when putting in a URL, it'll get to the right assertion all the time anyway. So we basically just have to worry about the transaction hash. And so uh, if the transaction hash exists, we are going to use an A element and set the href to testnet oracle UMA XYZ transaction hash, and then put our transaction hash in, and I'll just use an event index of 0. And by setting target equal to underscore blank, that's going to open the link in a new window. And so now getting into our last component, we have request payout, which is going to be the button for requesting payout for an open policy. And so we are defining the component here and passing in policy ID and refetch policy as props, and using this interface as the type for those props. And then this is pretty similar to the transaction execution flow we used earlier in new policy. So we're using the prepare insurance v2 request payout WAGMI hook, and we're passing in the policy ID as the only argument, and that config is passed into the use insurance v2 request payout React hook, and write is the actual function that we will use to execute the transaction. So yeah, same as before. Basically, prepare is going to check if the transaction is valid, and if it is, we will have the right object passed to us. And then we're using the use wait for transaction hook and pointing it at um, the transaction hash returned by this React hook. And after that transaction is complete, we're going to refetch the policy. So it's going to go back to policy data and hit refetch policy, which is going to pull the policy information from the blockchain again, which will update the status on our table row and change the request button also to the Oracle link for the newly requested payout. And then in our returned HTML, same as before, we're going to disable the button if write is falsy, if basically if that transaction is not available to us right now, or if the transaction is currently loading. And on click, we're going to hit the write method. And so now getting into our last component, we have request payout, which is going to be the button for requesting payout for an open policy. And so we are defining the component here and passing in policy ID and refetch policy as props, and using this interface as the type for those props. And then this is pretty similar to the transaction execution flow we used earlier in new policy. So we're using the prepare insurance v2 request payout WAGMI hook, and we're passing in the policy ID as the only argument, and that config is passed into the use insurance v2 request payout React hook, and write is the actual function that we will use to execute the transaction. So yeah, same as before. Basically, prepare is going to check if the transaction is valid, and if it is, we will have the right object passed to us. And then we're using the use wait for transaction hook and pointing it at um, the transaction hash returned by this React hook. And after that transaction is complete, we're going to refetch the policy. So it's going to go back to policy data and hit refetch policy, which is going to pull the policy information from the blockchain again, which will update the status on our table row and change the request button also to the Oracle link for the newly requested payout. And then in our returned HTML, same as before, we're going to disable the button if write is falsy, if that transaction is not available to us right now, or if the transaction is currently loading. And on click, we're going to hit the write method. And so now I'll flip over to our browser so we can see the finished product. And oh, shoot. I guess I'll leave this in as a blooper reel here if you made it this far. I already know what went wrong there. That is going to be in our policy data component. I pasted in all the table headings to remind myself what they were. And so if I delete those out and hit refresh here, we have all the information in here from the insured events, the beneficiary, the amount, the status. You can see the closed and requested policies have the link to the Oracle, and the open policies have the request payout button, which will start a transaction to assert the event happened to the Oracle. And I'll test out one of the links to the optimistic Oracle. Yeah, so you can see this is the assertion, and it's saying insurance contract is claiming that insurance event flood had occurred as of that timestamp. So thanks for following along. Hopefully you learned a fair bit about how WAGMI can help make your Dapp more performant and have a better UX and also speed up your development. And yeah, there's definitely some extensions you could continue on this Dapp from here. You could add some styling using just vanilla CSS or a library like Tailwind CSS. You could move the Dapp to the server side and have a backend that stores state rather than querying it all on the client side every time.